Hello everyone, I'm Yuxin Chin from JD.com. Today, I'll discuss our paper, InnoAds-Composer, Efficient Condition Composition for E-Commerce Poster Generation. Let's dive into the details. Let's begin with e-commerce product poster generation. We propose InnoAds-Composer, a single-stage framework that enables efficient tri-conditional control tokens over subject, glyph, and style, to alleviate the quadratic overhead introduced by naive tri-conditional token concatenation. We perform importance analysis over layers and time steps and route each condition only to the most responsive positions, thereby shortening the active token sequence. Besides, to improve the accuracy of Chinese text rendering, we design a text feature enhancement module, TFEM, that integrates features from both glyph images and glyph crops. To address these issues, we propose InnoAds-Composer, a single-stage framework that enables efficient tri-conditional control tokens over subject, glyph, and style, to alleviate the quadratic overhead introduced by naive tri-conditional token concatenation. We perform importance analysis over layers and time steps and route each condition only to the most responsive positions, thereby shortening the active token sequence. Besides, to improve the accuracy of Chinese text rendering, we design a text feature enhancement module, TFEM, that integrates features from both glyph images and glyph crops to support training and evaluation. We also construct a high-quality e-commerce product poster dataset and benchmark, which is the first dataset that jointly contains subject, text, and style conditions. Extensive experiments demonstrate that InnoAds-Composer significantly outperforms existing product poster methods without obviously increasing inference latency. The left panel presents typical cases composed of 3 customized inputs: a background style image that conveys global aesthetics and background elements, a subject image that specifies the product and its approximate location, and a glyph image that provides the textual content to be rendered. The right panel summarizes the pipeline. Images are first grouped by stock keeping unit, a unique identifier for each distinct product, and annotators select visually similar pairs within each group. For one image in each pair, QuickEdit removes product content to obtain a clean style reference. When needed, a super resolution model improves clarity. The reference and its paired image are concatenated into a diptych, and the reference side is recorded. These diptychs then supervise a fine-tuning of QuickImage so the generator learns to produce style-consistent counterparts, yielding clean background references. The framework comprises 3 modules. 1. Multi-condition tokenization, which maps heterogeneous controls into a shared token space and aligns them with the MMDIT backbone. 2. Importance-aware condition injection, which routes each control to its importance layers to improve efficiency while preserving controllability. And 3. Decoupled attention, which allows the mainstream to attend to condition cues while the condition branch performs self-attention only, removing the extra path to reduce cost and maintain training inference consistency. InnoAds-Composer is developed based on the Flux model, which is pre-trained on a large-scale text rendering dataset AutoPP1M and possesses an intrinsic awareness of Chinese characters. The model is further optimized under tri-conditional control using our InnoAds-Composer negative 80K dataset through an II stage training strategy. 1. In stage I, we fine-tune all MMDIT blocks using LoRa modules with a rank of 256, and the training process requires approximately 1.1K GPU hours. 2. In stage 2, we removed selected tokens and fine-tuned the network to minimize performance degradation. During this stage, and training was conducted for approximately 100 GPU hours based on the checkpoint from stage I. All training processes were conducted at a resolution of 800x800, using Ascend 910B. During the inference phase, to ensure a fair comparison with open source models, we used the A100 for evaluating performance and inference latency. The baseline models exhibit clear limitations when applied to the task of product poster generation. FluxFill and USO can only perform image synthesis driven by either a subject reference or both subject and background reference images, respectively, but neither is capable of generating images containing visual text, making them unsuitable for poster creation scenarios that require integrated textual elements. Poster Maker, while capable of generating images with both the specified subject and embedded text, struggles to maintain background style consistency, often failing to reproduce the desired stylistic characteristics of product posters. In contrast, Image Edit and CDream 4.0 demonstrate relatively good subject consistency and visual text rendering capabilities. Nonetheless, they often produce redundant or mismatched text, and their style transfer tends to exhibit a copy and paste effect, failing to generate diverse or contextually coherent backgrounds based on the style images. Our proposed InnoAds-Composer effectively overcomes these limitations, achieving strong consistency across text, subject, and background style. It is capable of generating visually appealing, semantically coherent, and stylistically controlled poster images, demonstrating its practicality for multi-conditional product advertisement generation. Table presents the quantitative comparison across all baselines and our proposed InnoAds-Composer under two configurations, Stage I and Stage II. Overall, in Stage I, our method achieves the best performance in nearly all aspects. It obtains the highest Senator ACC of 0.857 and NED of 0.976, indicating superior visual text generation quality. In terms of subject consistency, it also leads with a Dino score of 0.923 and an IOU of 0.972, demonstrating strong alignment between the generated subjects and their references. For background style consistency, it attains a CSD of 0.729 and a CLIP-I score of 0.582, showing stable preservation of scene style. Moreover, it achieves the best overall image quality, reflected by an IR score of 1.036 and a FIT of 54.39, significantly outperforming all open source and commercial competitors. After Stage 2, our method maintains comparable performance while improving computational efficiency, by performing importance analysis across layers and time steps and routing each condition only to its most responsive regions. Stage 2 effectively shortens the active token sequence and curbs quadratic compute growth. Although it shows a slight decline in most metrics, its overall quality remains competitive, achieving a Senator ACC of 0.847, Dino score of 0.914, and FIT of 55.24. This balance between accuracy and efficiency highlights the scalability and practicality of the proposed multi-conditional generation framework. We further evaluate the computational efficiency of our method in terms of inference latency, flops, and GPU memory consumption, as summarized in table. Leveraging decoupled attention, Stage I reduces latency by 26.5% and flops by 24.2% compared to Flux Context, which uses native full attention, with notably lower memory usage. Stage 2 builds on this by pruning redundant tokens and applying adaptive fine-tuning, achieving further reductions of 37.8% in latency and 38.1% in flops, without compromising generation quality. These results demonstrate that our combined decoupled attention and token pruning strategy significantly improves efficiency while maintaining high-quality output, striking a strong balance between performance and resource usage. We presented InnoAds-Composer, a single-stage, multi-condition framework for e-commerce poster generation that delivers simultaneously subject, text, and design style. By unifying subject, style, and glyph, text tokens in the same space and preserving the priors of an MMDIT backbone, our approach enables joint inference without multi-stage pipelines. The proposed text feature enhancement module, TFEM, fuses single entire glyphs with positional information, substantially improving text sharpness, boundary integrity, and readability. Complementing this, we perform importance-aware condition injection and decoupled attention to reduce redundant interactions and shorten the activated sequence, leading to improved inference efficiency. To facilitate learning and fair comparison, we constructed InnoComposer -80K and the evaluation benchmark InnoComposer Bench, covering subject, text, style, and overall quality. Thanks for coming. If you have any questions or would like more information, please contact me.